Well, so good morning. In this class, we are going to discuss about the expansion device in a vapor compression refrigeration system. So we have already seen what are the different components of this vapor compression system. Okay, and what is the functions? What is the function and importance of each and every component? So in this session, we are going to discuss about what are the different types of these expansion devices and their construction and working. So first of all, in this, our objective is to know what is meant by an expansion device and what are the various types of expansion device. And the capillary tube is also one of the expansion device. We will discuss about the merits, demerits, construction, working of the capillary tube. This capillary tube is also called as a metering device or measuring device, and it is also called as throttling device. So, because in capillary tube, the thermodynamic operation throttling takes place. So that's why this is also called as throttling device. We know that in throttling process, the pressure drops drastically. So due to the drop in pressure, the temperature also drops as well. The enthalpy remains constant. So this is the basic principle of throttling, and this expansion valve ensures these events to occur in a vapor compression system. And the location of any expansion device in a VCR system is between the receiver and evaporator. And after the condenser, there will be a receiver. After that, expansion device is located. And after the expansion device, the refrigerant from the expansion device will move to the evaporator. And this separates high pressure and low pressure sides of the refrigerant. So in an evaporator, the pressure drops. That's why the refrigerant, before entering into the evaporator, expansion device, have high pressure, and the refrigerant which leaves the expansion device will have low pressure. As the pressure is decreased in this expansion device, that's why it acts as a barrier between the high pressure and low pressure zones. So it's not a barrier, it is a separation. And there are different types of expansion device, like a dry expansion device and expansion device. Especially these dry expansion devices are used with the dry expansion evaporators, which we have discussed in the last class. And other expansion devices are used with the flooded type evaporators. Okay, so the expansion device which are used with the flooded type evaporators are known as float valves. Now, what are the functions of this expansion device? We know that already it reduces the pressure of the liquid refrigerant which is coming out of the condenser. So the refrigerant have high pressure in the condenser, and this pressure is reduced to low pressure in this expansion device, and this low pressure liquid refrigerant is sent to the evaporator further. And also it supplies the refrigerant according to the load on the evaporator. The load on the evaporator may fluctuate depending upon the weather conditions or any other things. So according to the load, it supplies the quantity. That means it regulates the quantity of refrigerant which is moving into the evaporator based on the load conditions. Now, what are the different types of expansion device? The first one is capillary tube, thermostatic expansion valve, automatic expansion valve, solenoid valve, high side float valve, low side float valve. So we have the capillary tube and the thermostatic expansion valves are there in our syllabus for C20 curriculum of AP SBTET. That's why we are going to discuss about the capillary tube and the thermostatic expansion valve. Initially, we see about the capillary tube. So this is basically the capillary tube. So here, the thing which is the form of a spring, a spiral thing. So on the left side, this is called as a capillary tube. And at the end of the capillary tube is connected to the evaporator. So this is the evaporator. See, this is the capillary tube. Okay, and this portion is the evaporator. That means the liquid refrigerant which is coming out of the capillary tube is entering into the evaporator. So we have seen the capillary tube already while doing our project work in the college. So it is nothing but a small tube, a tube having very small diameter, and in that tube, the whole of the tube is again having a smaller diameter. The diameter of the hole is further reduced compared to the outside diameter of the tube. Okay, so due to the low diameter, due to the small diameter, it offers resistance to the flow, due to which the pressure is reduced. Let us see one by one. It is basically a small diameter tube, and it is connected, of course, between the condenser and evaporator, as we discussed earlier. And it is of constant restrictive type device. That means it offers restrictions to the flow of refrigerant, which is coming out of the condenser. And due to this restriction only, the pressure drop takes place. And the required pressure drop is obtained due to the heavy frictional resistance offered by the tube. Since this capillary tube offers restrictions to the flow, that means it offers resistance to the flow. Actually, this is the normal tube. This is the normal refrigerant tube which is coming out of the condenser. And now from here onwards, the diameter of the tube is reduced drastically like this. So due to the sudden change in the diameter to a smaller one, this tube offers resistance to the flow of refrigerant which is moving through this. So due to the resistance, the pressure is dropped greatly. And as the pressure is dropped, the temperature also drops. Okay. Next. The frictional resistance is directly proportional to its length and inversely proportional to its diameter. So here, as the diameter decreases, it offers more and more resistance to the flow. And that's why this diameter is inversely proportional. If the diameter decreases, resistance increases. They are inversely proportional to each other. And as well as the length of the tube. See here, the length of the tube will be higher. If you observe, the length of the tube will be higher. So this is in the form of a coil like this. So that's why the length of the tube will be higher. As the length increases, the resistance also increases. As the resistance increases, the pressure drop also increases. So that's why we have to be careful while deciding the length of the capillary tube. As the pressure drop depends upon the length. As the length is increased, the resistance is increased. That's why the pressure drop is increased. So while calculating the length of the capillary tube to be installed, we have to take the consideration of the required pressure drop. Right. Next one. And the application of this capillary tube is generally it is used in our domestic refrigerators or freezers, which we use at our home, and water coolers, and some small freezers which are used commercially in shops, everything, everywhere. Okay, so these are the applications of capillary tube. And the refrigerant enters into the capillary tube due to the frictional resistance offered by the small diameter tube. The pressure drop takes place. That's what we have discussed. And this capillary tube is suitable up to 1 ton capacity refrigeration units. That's all. And coming on to the merits or advantages of capillary tube, it is simple in construction and there is no maintenance. There are no moving parts. Simply it is a tube. That's all. That's why there is no maintenance required. And the cost is also very less, very, very less. And it is a leak-proof device since it is made of some copper, and there is no chances for leakage. This capillary tube is brazed together with the refrigerant pipes at the entry and at the exit. So the leakage depends upon the perfectness of the brazing. That's all. There is no chances of brazing, leakage, the capillary tube, and it doesn't require the valves and the receivers. So ఇందులో మనకి valves కానీ receivers కానీ ఏవి ఉండవు. But if you see other types of expansion device, there we use valves, receivers, everything, but there is no requirement of such valves and receivers in this capillary tube, right? Coming on to the demerits, and it cannot be used for high fluctuating loads. So when the loads are fluctuating drastically from top to bottom, from high level load to low level load continuously, so in such cases this is not suitable because it cannot alter the flow immediately and continuously. Therefore it is not suitable. And the refrigerant which is moving through the capillary tube must be free from moisture and dirt, because since the temperature drops inside the capillary tube, if there is any moisture, that may be converted into ice and that will clog the capillary tube. So that's why the flow is completely stopped. Similarly, any dirt particles or dust particles may clog the capillary tube, so which will choke the tube. Choke means stopping the flow. So that is about the capillary tube. And the next one is thermostatic expansion device. We'll discuss. So this is thermostatic expansion device. So just observe what are the various components in this thermostatic expansion device. Here it consists of a valve. So where is that valve? See, here is this. Okay, so this is the valve. I think you are able to see my cursor. Okay, so as the and this is the entry into the expansion device. See, this entire unit is called as expansion device, and this is the evaporator coil, and there is a valve in it. Okay, and there is a diaphragm also. See, this is called as diaphragm. Just wait. Fortunately, diaphragm is not shown here. Yeah, here it is. Diaphragm is shown in the top, and in different textbooks it is shown differently. And now this is the diaphragm. Okay, so this upper plate is called as the diaphragm, and this one is the valve, and this is the valve seat. See, so this is the valve seat, and this is the valve. Okay, and this is called as diaphragm. See, this entire unit is diaphragm, and this diaphragm is a flexible one. That means if pressure acts in this direction, it will bend in this way, so that it moves the valve downwards, so that it makes some opening between these two. But when the pressure acts upwards, like this. Now suppose when the pressure acts upwards, then it will bend like this, so that this valve will also upwards, so that it closes this opening. That's why the flow is restricted or stopped. This is how it operates. Okay, right. Now, how the movement of diaphragm takes place. So here, if you observe, there is a bulb. So this is the bulb. This bulb senses the temperature of the refrigerant which is coming out of the evaporator. So what happens in the evaporator? The liquid refrigerant which is moving into the evaporator is initially a liquid refrigerant with low temperature. Okay, now this refrigerant absorbs the heat in the evaporator during its flow, and finally it is converted into vapor, and sometimes it may be converted into superheated vapor. So here, this bulb senses the temperature of the superheated vapor. If the temperature of the superheated vapor is high, then what does it mean? That means the load on the evaporator is very high. When the load on the evaporator is very high, the refrigerant is superheated. That's why then the fluid which is there inside the bulb also gets heated, and this fluid will move into this. This fluid will move through this pipe, and the pressure of the fluid is communicated to this diaphragm. So that's why this pressure will act downwards. So due to the pressure acting downwards on the diaphragm, it moves. So this will be bent like this, and then due to this wall will move downwards. That's why it makes more opening in the wall. That's why more quantity of refrigerant is entered into the evaporator. Now, for example, the temperature of the refrigerant which is coming out of the evaporator is low. So that's why here the pressure of the fluid inside the bulb is also low, and so the pressure inside this tube and the pressure communicated to the diaphragm is also low, due to which again it comes to the initial position. Just let me show you. So when the pressure is low, again it comes to its initial position like this. Now, due to this, it will move upwards once again. So when it moves upwards, this opening is reduced, so that minimum quantity of fluid is sent into the evaporator. So that's why, depending upon the load, this thermostatic expansion device sends the required quantity of refrigerant into the evaporator. So this is the construction and working of this thermostatic expansion device. Is it clear for you? Right. Now coming on to the, actually this matter is different. This presentation is not prepared properly. We just check how this thermostatic expansion valve is operated. So for example, here it consists of this valve is operated by means of a spring. It is connected to the bottom screw by means of a spring. So this spring should always be in expanded position. When the spring is compressed, this spring will always try to move the valve upwards. So that's why the spring pressure will act upwards. So let this P1. Okay, so let this P1 is the spring pressure, and P2 is the pressure of the refrigerant in the evaporator, so which also acts in upward direction. Okay, so and the pressure of the refrigerant or the pressure of the fluid in the bulb will act vertically downwards. Acts vertically downwards on the diaphragm from its top. Okay, now if the pressure from the top is equals to the sum of the pressures from the bottom, then the position of the diaphragm will be like this. So this is called as normal load. But when the load is increased, then what happens? This upward pressure increases. So when this upward pressure is increased, and if it is greater than these two pressures, then this valve is bent like this, and hence this valve is, the diaphragm is bent like this, and the valve is open, so that more quantity of fluid is entered. And under low load conditions, low load, now these two pressures, the sum of these two pressures will be higher than this one. In such cases, it may bend like this. The diaphragm may bend like this, so that it completely closes the valve. Thereby, the complete prevention of the flow into the evaporator, or very few quantity of refrigerant enters into the evaporator. Okay, is it clear? So that's all. these two are there in your syllabus. And in textbook, there are others, different types like solenoid valve is there, and one more thing is there. What is that? Automatic expansion valve is there. Those two things are not there in syllabus, but it is better to prepare those things also. Okay, but since the time is not sufficient, I'm skipping those out of syllabus. Any doubts? Well, so that's all about these evaporative, sorry, expansion devices. So we have seen all types of expansion devices, and there are few things about the dryers. So what is meant by dryer? So dryer is nothing but it is fitted, it is a cylindrical vessel which is fitted between the condenser and expansion valve. ఇందాక చెప్పుకున్నాం ఎక్స్పాన్షన్ వాల్వ్ కి కండెన్సర్ కి మధ్యలో డ్రైయర్ అనేది ఉంటుంది. ఓకే, సో దిస్ డ్రైయర్ ఎన్షూర్స్ the removal of moisture content present in the refrigerant. So the refrigerant should be free of moisture before entering to the evaporate expansion valve. As the temperature is reduced, any moisture may cause blockage of flow inside the expansion device. So that's why any moisture should be removed just before entering to the expansion device. For that purpose, these dryers are used. And this dryers uses a material called as desiccator. So this desiccator is used for drying, and this desiccator absorbs the moisture. So if you order anything online or mobile phone or anything, you will see a small pouch inside that packet. So which is nothing but a desiccator, which absorbs the moisture from the box, like that. And there are different types of dryers like throwaway type dryers and refillable type dryers. So throwaway type dryers are used only for once. Once the complete descent is out, then they can be simply thrown away and it has to be replaced with a new one. These throwaway type dryers are also called as non-fillable, non-refillable or seal type dryers. And the next one is refillable dryers. So once the descent material is out inside these refillable dryers, they can be replaced. Only that descent material can be replaced, not the entire dryer. Okay, so and there are different diagrams related to this. You just go through your textbook, right? So that's all about the various components of these things. Now we shall discuss the applications of the second part of the third chapter, applications of refrigeration. Right. Yeah. So applications means where we use this vapor compression system. So there are different applications. Let me show you one by one. So I think all of you are having the refrigerator or fridges at your home. Okay, so what is the use of your fridge at your home? That is used to store the food products, fruits, milk, meat, whatever be the commodities. We can store them in a chilled atmosphere in a refrigerator, and you can observe different areas in your refrigerator which we use. Okay, and before invention of this refrigerator, and what are the things which were used to produce the cooling water or other materials? So that also we don't know. And do you know some applications of refrigeration for reducing the temperature and preservation of foods and manufacturing of ice? This manufacturing of ice is nothing but ice plant, and the preservation of food is nothing but our refrigerator is also used for preservation of foods and the reducing the temperature. So this is also one of the example, and our air conditioner is also one of the example for this one. Okay, so domestic refrigerator, ice plant, and water cooler, cold storage. So these are the applications that we are going to discuss. So first of all, domestic refrigerator or fridge, even though it is called as domestic, it can also be used in hotels, offices, shops, and the commercial things. So this domestic refrigerator generally it is specified in terms of liters. So if you go to a shop and ask for a refrigerator, immediately he asks you regarding the capacity in liters. Okay, so you have to say I need an 80 liters refrigerator or 165 liters refrigerator, etc. This is nothing but the total space inside the refrigerator. Okay, and it works on vapor compression cycle. That means it consists of all the four components which we discussed in vapor compression cycle. So its main parts are compressor, condenser, evaporator, and expansion device. And here the expansion device is capillary tube. Okay, so this is our refrigerator. And this is the layout of the refrigerator. So this is a schematic diagram which represents various parts in a refrigerator. Now observe various components in this refrigerator, and the compressor is located at its bottom. If you go to your refrigerator and observe at its back, then you can see this compressor which is there at the bottom, and there are two lines from this compressor. One is suction line and the other one is the discharge line, and the suction line comes from the evaporator, and this evaporator is located at the top. If you see, your pressure box is nothing but the evaporator, in which the evaporator coil is placed, and it is located at the top, and the entire fridge space is cooled by the cooling produced in the evaporator. Okay, see, and here the capillary tube placed here. Okay, you just observe the refrigerant which is coming out of the evaporator is moving into a device called as accumulator, where the fluid is accumulated, and then it is moving through a heat exchanger. So while moving through a heat exchanger, it absorbs an amount of heat from the fluid which is moving into the evaporator. Okay, now then this is given as suction to the compressor. Now in this compressor, the fluid is the refrigerant is compressed to high pressure, so that this high pressure and high temperature refrigerant will then move into the condenser. So this condenser is seen on the back of your refrigerant. So మీకు ఫ్రిడ్జ్ వెనకాతల మీకు పొడుగ్గా ఉంటాయి, పైపులు ఉంటాయి చూడండి, వాటి ఫిన్స్ కూడా ఉంటాయి. So it is provided with fins in order to increase the heat transfer area. Okay, and then from where here the high pressure vapor refrigerant is converted into high pressure liquid refrigerant, and again this liquid refrigerant is sent to the dryer. So before entering to the capillary tube, it must pass through the dryer, where that amount of moisture, if is there any, that is absorbed, and then again it moves into the heat exchanger. After that it enters into the capillary tube, and after capillary tube again it enters into the evaporator. So this is our domestic refrigerator. Is it clear for you? Right. Now various parts. Compressor, so generally this is hermetically sealed rotary type compressor. So we have seen different types of compressors, rotary, reciprocating type, but here in our fridge a rotary compressor is used, and it is hermetically sealed. That means here the compressor is directly mounted on the electrical motor, and the entire unit is completely sealed. So we have discussed already in the compressor section about this hermetically sealed compressors, and it is provided at the back side as the cabinet plate case. And generally the refrigerant is used Freon 12, but in olden days we use it to have this Freon group, but now they are completely eliminated due to the environmental concerns. And the compressor compresses the vapor refrigerant received from the evaporator. So that's we have already discussed, and it increases the pressure and temperature, and also it provides driving force into the system. So it drives the refrigerant throughout the system. That means it pumps, it ensures the flow of refrigerant through the system, right? So that is about the compressor. Now coming on to the condenser, it is also provided on the back side of your refrigerator. This is a grill-like structure. So if you observe on the back side of your refrigerator, you can observe this condenser just like a grill. Okay, it may be tube and wire type. This wire acts as fins ఆ వైర్ అనేది ఫిన్స్ లాగా యాక్ట్ చేసి హీట్ ట్రాన్స్ఫర్ రేట్ ని పెంచడానికి ఉపయోగపడుతుంది. ఓకే, అండ్ ఇట్ కండెన్సెస్ ద వేపర్ రిఫ్రిజిరెంట్ బై ఎయిర్ సర్క్యులేషన్. Here this is a natural convective type, and here the cooling takes place by means of air which is surrounding the condenser. There is no need of separate fan. So this is a natural circulation type. But in our college, we have used a condenser with a forced circulation type of cooling. There we used a fan. Okay, but in our refrigerators, there is no need of fan. And the vapor refrigerant is converted into liquid state by using its latent heat. So the in condenser, the vapor refrigerant which is entering into the condenser will lose its heat, only latent heat, so that the refrigerant which is entering into the condenser is initially dry and saturated, and after that, after the condenser, it is dry saturated liquid. So initially it is dry saturated vapor, after that it is dry saturated liquid. That means it has lost its latent heat only in the condenser. And the next one is capillary tube. So it is also an expansion device. It gets the refrigerant from the receiver. Receiver is a temporary storage. Okay, so based on the load conditions, the capillary tube sucks the required quantity of refrigerant from this receiver, and the diameter of the capillary tube very narrow. So this also we have discussed. So it is action. It is attached to the suction line through heat. That means it is brazed to the suction line. Sorry, it is through heat exchanger. Okay, so in capillary tube, the pressure is reduced as well as the temperature. And the next one is evaporator. So this is generally provided on the top portion of the inside cabinet. The entire unit is called as cabinet. So this evaporator is provided at its top. So in this evaporator, the liquid refrigerant which is entering into the evaporator is having low pressure and low temperature, and it absorbs the heat from the space or the products in the refrigerator, and this liquid refrigerant is converted into vapor. And the amount of heat absorbed is also assumed to be the latent heat. It is equal to the latent heat. And the temperature generally will be between 7 to 10 degrees. Usual temperature in the evaporator is 7 to 10 degrees, but in our modern refrigerators, it is further reduced. The refrigerant vapor is then sent into the suction line back to the compressor. Okay, the refrigerant which is leaving the evaporator is moved to the compressor, and accumulator is a device which collects the refrigerant and prevents entry into the compressor. So we have to send the refrigerant vapor only into the compressor. Any liquid which is not converted into vapor should be stopped entering into the compressor. So for that purpose, this accumulator is used. So it separates the liquid refrigerant, if any, and it sends only the vapor into the compressor. So that's all about this one. And the next application of the VCR system is the ice plant, in which ice is produced. So in our refrigerator also, we produce ice in that freezer, but it is very small in quantity. But if you need ice in huge quantities, like for commercial applications, then these ice plants are used. Just see. So this commercial ice is used generally during transportation for preserving the food items. Okay. Similarly, drinks, cool drinks. So generally, if you go to a shop, then you will get the drink for you from the refrigerator. But if you see in a train, there are no refrigerators. In such cases, they bring those cool drinks along with the ice in a separate cartons, so that the cooling is preserved. And now we shall see how these ice blocks are produced and what are the practical uses of these ice blocks in this presentation. So this is the layout of a basic ice plant. If in every application, the components are similar, except the evaporator, because the evaporator is the only place where our purpose differs. Okay, so here our purpose is to produce ice. That's why the construction of evaporator is somewhat different. Okay, however, the evaporator tubes are run over this one. So here also there is a compressor, and there is a condenser, and there is an expansion device, Here, the expansion device is not a capillary tube, which is used for low applications, low capacity applications. So here we have to use the expansion device which shoots to the high capacity units. Okay, see, uh, so this is basically the ice chamber, the evaporator chamber, and here, if you observe, these are the ice tanks in which the water is filled, and this water is converted into ice. And this tank is called as brine tank. So brine is nothing but it is the sodium chloride solution, uppu neelu. And it can be used as secondary refrigerant also. Now, these evaporator lines, these evaporator lines, they are wound throughout this evaporator in the brine solution, so that the brine solution gets cooled, and this in turn the brine solution will absorb the heat from the water inside the ice cans, so that this water is converted into ice. And again, after that, the refrigerant is sent to the compressor, and from this compressor again it is sent to the condenser. We know all the functions of these parts like compressor, condenser, and again it is a receiver. It is a temporary storage device, a dryer, expansion valve. Again, in expansion valve, the pressure of the refrigerant is greatly reduced and the temperature is also reduced, and this low pressure, low temperature refrigerant is sent into the ice chamber. Okay, let us see. So this is used to manufacture ice from the water. It consists of MS plate tank. So MS plate tank అంటే ఇప్పుడు చూసాం కదా, ఈ రకంగా ఈ షేప్ లో ఉన్నాయి. Just a second. So this is an MS plate tank, and it consists of insulation material around it. Okay. And this tank is completely filled with the secondary refrigerant, generally brine solution, up to the required level. And this ice are made in galvanized sheet. That means the ice cans, this ice causes kaadu, these are ice cans. These ice cans are made with galvanized iron sheets. Okay, so these ice cans are in this shape. So these are the ice cans. They're made of galvanized iron, and these are not cages. This is cans. Just a second, getting a call. Now the water inside these ice cans are converted into ice. Okay, why this particular shape is provided? Why not this shape? Tell me. Why ice cans are provided in this shape only? Why not this shape? Tell me. This shape is not suitable. Even this shape is also not used. So this is this particular shape is used for easy removal of ice after freezing. Okay, so ice can be removed easily from these cans, right? Right. So, and air agitators are used to force the dissolved gases, if any, and solids to the central core of the can. So there are certain devices called as ice agitators, which are used to force dissolved gases, if any. So is there any water? The water may consist of different types of dissolved gases. So that's why these air agitators are used to remove such gases and the solids to the center core of the can. And these are pumped out and replaced with fresh water. So this is done before filling the water into the cans. So whatever be the air which is there inside the can has to be removed, and whatever be the solids or dust also has to be removed by using this air agitator. And after that only it has to be filled with fresh water. And we have already seen about the construction of it is rectangular in cross section and slightly tapered inwards. Okay, and a hoist, it is not harsh, and a hoist is provided to lift the can from the tanks. So once this ice is made, these cans are removed from the tank, and after that the ice is removed from the cans. This is hoist, H-O-I-S-T. and it also works on the principle of vapor compression system, and it uses refrigerant ammonia. So it uses ammonia as primary refrigerant and brine solution, which is sodium chloride solution or calcium chloride along with the water as the secondary refrigerant. And mostly ammonia is used for high capacity applications, and for low capacity applications we may use R12, that is Freon-12 or R22. Okay, and here the ice is manufactured from the water. This is the working. Cans containing the water are cooled by the brine which is circulated around in these cans, and this brine is chilled by the refrigerant. So here just observe, the refrigerant cools the brine, and this brine in turn cools the water, so that the water is converted into ice. And the temperature of the freezing point of the brine is less than 0 degrees Celsius. You just observe. Up to minus 12 degrees, the brine can be cooled without freezing. So such minus 12 degrees brine is used to cool the water up to 0 degrees Celsius. So when the water is cooled up to 0 degrees Celsius, it is freezed. The high pressure ammonia vapor is delivered from the compressor and enters the condenser. So this is all you know. So this is again, once again, the vapor compressor, working of vapor compressor system. So what you have to do is you have to explain the construction of each and every element in any application like ice plant, refrigerator, and the working is similar to our vapor compression system. That's all. The only the difference is the evaporator. So generally this ice plant is used to produce ice, which are used to chill the cool drinks, and for transportation of perishable goods like dairy products, fruits, fish, etc. Okay. So the next application is water cooler. So here this is used to produce cooling water. So you may have seen these water coolers in different commercial establishments. Even in our college also there is a water cooler, but is very smaller in size. But you can observe huge sized water coolers, right? So what is the purpose? It is used to produce cold water, and the water cooler can be classified into two categories: storage cooler and instantaneous cooler. So storage cooler means it consists of a storage tank, and water is taken into the tank, and this water is cooled by the evaporator coils. Okay, and instantaneous cooler produces cooling instantaneously. So అప్పటికప్పుడు మనం వాటర్ తీసుకొని తాగే
పడుకుందామని మేమే చెప్పాం.
Mr. Naveen. But in case of storage cooler, it takes some time to get the cooling. But instantaneous cooler is not like that. We'll get the cooling water immediately. So the storage cooler, the cooling coil or the evaporator coil is wrapped around the water storage tank. Wrapped means chodaru. The juttu chodaru. This cold water is available all times. So whenever you need cold water, you can get it from the tank immediately. But in case of instantaneous cooler, you have to switch on the system once again to get the cooling water. And this is used where continuous water supply is not available. When there is no supply of water continuously, then you have to store the water. So this is why you can use the storage cooler. And in this case, the evaporator coil and water tubes run side by side. That means, say for example, I will show you. See, for example, this is the water tube, and the evaporator coil will be like this. Evaporator coil will be like this. So one run in another. So the refrigerant flows in this direction, and the water flows in this direction, so that there is an exchange of heat between the water outside this evaporator tube and the refrigerant inside the evaporator tube, so that at the end of the tube you will get cooling water directly. So it is instantaneous. There is no tank for this. Okay. And water is cooled to desired temperatures as it reaches the tank. However, here also they will have a tank which is used for temporary storage, but it is not mandatory. The main components of the water cooler are, these are the components which we know: compressor, condenser, strainer to filter the foreign particles, expansion device, generally capillary tube is used here also, right? Evaporator, storage tank, a thermostat which is used to sense the temperature and switch on the compressor as and when it is required. A thermostat is used in our fridge also, so that it stops and ons, it switches off and ons the refrigerator as per the temperature sensed by it. Okay. And insulator, heat exchanger. Okay. Now this is our water cooler. You just observe, this is a huge, a bigger water cooler. మన విజయనగరం కాలేజీలో చూస్తే ఇటువంటి వాటర్ కూలర్ ఉండేది ఒకప్పుడు, ఇప్పుడు లేదనుకుంటా. ఓకే, see this entire cabinet, this is the entire cabinet, and here at the bottom some components are provided and its top, this is a huge tank. This is a huge tank which is filled with the water. Sorry, this is not water, and this smaller one, whatever will I say, this is the only tank. Okay, and this one is nothing but the insulation which is used to prevent any flow of heat in and out of the system. Okay, well, now this tank consists of evaporator coils wound around it. So దీని చుట్టూ ఇలాగ evaporator coils అనేవి పెట్టి ఉంటాయి. Okay, and so these are the evaporator coils, and this is the insulation. Okay, and from here you can get the water through this tap. So this is the tap. Okay, and this is the water inlet from which you can send water into this, and this is the float valve which is used to stop the water supply when this tank is completely filled. Okay, and again the other refrigerant parts are same. Okay, see, this is our compressor which is placed at the bottom, and this condenser is also placed at the bottom. So after compressor, this is the discharge line of the compressor, and this is the condenser. After that, there is a strainer to filter any dust particles, whatever be there, and then this here, this is the capillary tube which is not clearly shown in this. This is the capillary tube through which the refrigerant flows, and here the temperature and pressure drops, and after that it flows through a heat exchanger, and then it is moved to the tank. So it flows through the evaporator coils which surrounds the tank, so that it absorbs the heat from the water, so that the water is cool. And again, the vapor which is coming out of the evaporator is dry and saturated vapor which is sent into the compressor directly. That's all. So if there is any wastewater, that can be drained through this piping. So if you want to clean the tank, then you have to switch off the system, and that water can be removed by using this wastewater outlet. That's all. Right. So this is a small type of water cooler. This water cooler is used in our college also. Okay, and the previous one is a water filter cum cooler. So the water coming, see, this is the tank, and here this is the filter. Okay, so there is a storage type water cooler. It consists of a storage tank filled with water, and the water level is maintained constant with the help of float valve. So the water cooler which we have seen is a storage type one, and insulation is provided around the tank to prevent any heat transfer. So once if you switch on the cooler in the morning and the cooling water is produced, even though there is no power, the chilling is continued until the end of the day if the insulation is perfect. So insulation is perfect గా ఉంటే కరెంట్ లేకపోయినప్పటికీ కూలింగ్ అనేది అలాగే ఉంటుంది. So the coils of the evaporator are fitted around the tank. So this is what we have discussed till now, and the refrigerant we use is 3 and 12. So again, once again, you have to explain the functions of each and every part in detail. Again, same, the compressor, condenser, then functions, అది ఏంటి అని రాయాల్సి ఉంటుంది ప్రతి చోట. As usual. So the next application is cold storage plant. So which are used to store any item, maybe food item, medicine, and or any other things. So they are used for cold storage. Okay. So here we are going to discuss about what is the working of cold storage plant. So these are not necessary. So the basic components of cold storage plants are compressor once again, condenser same, expansion device, evaporator coils, and this is the layout. So here if you observe on its right side, so this is the space to be cooled. This is the space to be cooled. And here is the evaporator coil. So this is the evaporator coil which produce the cooling effect inside this space. Okay. Well, and here a fan is provided maybe at the bottom, and air is flown over this evaporator coil so that the air is cooled, and this cold air is sent into the refrigerator space. So this is actually the space to be cooled. So here we keep our products. So the products are kept like this, maybe vegetables, meat, or any medicine like things. Okay. So that the cold air is then passed over the commodities to be cooled, and hence the cooling is produced. And remaining all are same. Say this is the compressor, condenser, receiver, expansion device are as usual. Okay. So you have to explain about each and every component of this one as usual. So మళ్ళీ చెప్పట్లేదు నేను. కంప్రెసర్ ఏం చేస్తుంది, కండెన్సర్ ఏం చేస్తుంది, రిసీవర్ ఏం చేస్తుంది, ఎక్స్పాన్షన్ వాల్వ్ ఏం చేస్తుంది, and the only difference is this space. And evaporator కూడా సేమ్ ఇక్కడే ఉంది, బట్ ఇక్కడ మనకు చిన్న డిఫరెన్స్ ఉంది, that you have to mention. So generally it is provided with facilities like quick freezer room and processing and preparation room, aging room, chill room. So these are the facilities provided in a cold storage plant. Cold storage is a space to be refrigerated, and it is designed to store the perishable foodstuff within the temperature limits and humidity. Okay, it prevents food spoilage. So when it is kept in cold atmosphere, any food item, it is not spoiled. That's why we keep our food like milk, meat, or vegetables in the refrigerator. Since at low temperatures, it is not spoiled. Right. And it also works on vapor compression system. Okay, the refrigerant which is flowing into the system keeps the evaporator coils cool, and the air from the room is drawn over the evaporator. So this is just like our air conditioner. So in our air conditioners also, air is drawn over the evaporator coils so that air gives away heat to the evaporator, the refrigerant inside the evaporator coil. The same concept is used here also, and for this purpose, some blowers are used to draw the warm air, and this air is drawn from the cold chamber once again. So in cold chamber, the air gets heated by the products. So that air is then cooled by the evaporator coil, and this cold air once again sent into the cold chamber, where again it absorbs the heat from the products. Like this, the cooling is maintained. So this is what was explained. And there are certain dampers which are provided. Okay, everything is same. Once again, he is explaining the working of each and every component like evaporator, condenser, expansion device. Okay, so that you have to mention while writing the answer.